Good morning to you all. Welcome into today's video. We are going to continue today with a number of definitions. We are going to give more definitions. Okay. Just a quick reminder of what we did say last time. If you remember from last time, we defined what we call independent variable, which are the variables that we have control over. This is the variables that we change during the course of the experiment, or we keep constant. Okay. We also defined dependent variables. Okay, and they are the values or the quantities that we measure during an experiment. If we recall what we said last time, a dependent variable in the experiment of a simple pendulum was the periodic time. Okay, so that was a dependent variable. The independent variables were the length, the weight, and the angle theta that we can either vary or keep constant. Okay. Today, okay, you again went into your physics lab. This time, your tutor did ask you to calculate the resistance per unit length of a wire. Okay, ask you to calculate the resistance per unit length of a wire, and he proposed this circuit where we have a power supply, we have power supply, we have ammeter, we have volt meter, and we have a piece of wire. Okay, so what we are going to do, we are going to connect this circuit. We close the switch, we measure the ammeter, the current using the ammeter, we measure the voltage across a certain length of the wire. Okay, and here are the measurements. Okay, but before proceeding further, let me define something for you, something that we call a true value. What I call a true value. And a true value is simply the value, okay, or the best known measured value for a physical parameter. What is the true value? It is the best measured value for a physical quantity, okay, or it is the value we know from some theoretical investigation of our phenomena. For example, as if we recall the experiment for a simple pendulum, the best known value for acceleration due to gravity is 9.81 meter per second square. Okay, this is the best known value for the acceleration due to gravity. So we typically say that this is the true value for the acceleration due to gravity. Okay, this is the true value for the acceleration due to gravity. So whenever you carry out any physical investigation, one good thing to know is the true value of the parameter that you would like to measure. You need to have, you don't know it exactly, but you need to have an idea about the range of the value. Okay, this will always let you check if your setup or your measurement or your experiment is right or wrong. Okay, we all know that the acceleration due to gravity is 9.81 meter per second square. So if you carry an investigation with a simple pendulum to measure the acceleration due to gravity, and you get something like 11 meter per second square, you know that you are a little bit off. If you get something like 75 meter per second square, then you definitely know that you are totally wrong. So knowing the true or the expected value for a measured quantity before carrying out an experiment is always important and instrumental. Okay, now let us go and see how close we can be to a true value of a physical quantity. Okay, now we got something that we call measurement uncertainty. So what is measurement uncertainty? So when we carried the experiment, we got this reading on the ammeter and we got that reading on the voltmeter. If we take a look at the voltmeter over here, then it is easy to read the value. Okay, we know from 0 to 1 on the voltmeter we have 10, let me write it in color which is more clear, 10 divisions. 10 divisions. Okay, 1 volt is 10 divisions. So what is a small? What is the smallest scale or value that can be measured with a voltmeter? With this voltmeter, then it is 1 volt divided by 10, which is 0.1 volts. Okay, so this small division is 0.1 volt. Okay, now can we take the measurement with me? Okay, this is till here it is 1, 1.1, 1.2 volts. So the measurement of the voltmeter is 1.2 volts. Let us come and do the same for the ammeter. Okay, so from here to here it is 0.1 amp. How many divisions? How many small divisions are? 1, 2, 3, 4, and 5. So 0.1 amp divide 5 divisions. This gives us small divisions of 0.02 amps. So any small division here is 0.02 amp. Okay, now let us take a reading. So till this point it is 0.4. This one is 0.42. So the best that we can say about the voltmeter is that, sorry, about the ammeter is that the current is between 0.4 amp and 0.42 amp. So anything between those two values is correct. Anything between those two values is correct. It could be 0.41 amp, sorry, it's correct. Could be 0.415 amp, which is again correct. Could be 0.418, again correct. Could be 0.409 amps, which is again correct. Okay, so you notice here that since the scale or the pointer was between two lines or two scale lines, we had an uncertainty in measuring the scale. We had an uncertainty in measurement the scale. This would induce what we call measurement uncertainty. Okay, this what would induce what we call what? Measurement uncertainty. Okay, so we have a scale. This scale comes between two lines. Okay, we cannot say exactly where it is. Okay, so we need to uh, guess a value between 0.4 and 0.42. Anything between them is correct. Okay, anything between them is correct. So let us say that we decided that the measure value on the voltmeter is 0.41 amp. Okay, and on the on the ammeter it is 0.41 amp, and on here it is 1.2 volts. Okay, so we notice that since our instruments are limited, okay, we can have only a few number of divisions in any scale. Okay, then we got measurement uncertainty. Okay, what about here? Is the value of the voltmeter exact? You might be intrigued to say, yes, it is an exact value since it is 1.1, and it is exactly on 1.2 volts. But unfortunately, this is not true. And let me explain more why this is not true. So if you remember from your electronics or electricity chapters, okay, you were told that an ideal ammeter must have zero resistance. But our ammeter, or all ammeters that we can make, can never have zero resistance. Okay, they can be very small, but they can never be zero resistance. Any ammeter in the world, okay, whatsoever we try to do, ammeters can never have zero resistance. They can have very small resistance, but they can never be zero. So since our ammeter is not ideal, so the measurement or the current measured by the ammeter can never be the exact or the true value of the current passing through the circuit. Okay, it can be close enough. It can be close enough, but it can never be the true value of the current passing through the circuit. Okay, this is about the ammeter. What about the voltmeter? We know that an ideal volt meter need to have an infinite resistance. Okay, but again, our voltmeter can never be ideal. Okay, an ideal voltmeter need to have infinite resistance. There is nothing in the world that is called infinite. We can have very large resistance, we can have huge resistance, but it can never be infinite. Okay, so again, are we measuring the exact or the true value of the voltage across the wire? No, we cannot measure the exact value or the true value of the voltage across the wire, but we can be very close to it. We can be very close to it. Okay, so whenever you use a measuring instrument, whether it is electronic like voltmeters, ammeters, digital voltmeters, ammeters, stopwatch, whatsoever, a meter ruler, a micrometer, a vernier, whatsoever you are measuring, how expensive your instrument can be, okay, it will always have a measurement uncertainty. It will always have a measurement uncertainty in any value you measure. Okay, it will always have a measurement uncertainty in the value that you measure. You have to bear this always in your mind. Okay, whatsoever you do, okay, there will always be measurement uncertainty. So what is a measurement uncertainty? It is the uncertainty caused by using measuring or measurement instruments. Okay, how does it affect the final result of our experiment? It will cause measurement error. Okay, it will cause what? Uncertainty. In measurement will lead to measurement errors. Okay, so what is a measurement error? A measurement error is simply defined as the difference between the true value and the measured value. Okay, measurement error is the difference between what? The true value and the measured value. A simple example, we can quote the acceleration due to gravity. True value, g is equal 9.81 meter per second square. We carried out the experiment ourselves. We got 9.71 meter per second square. Okay, so the measurement error is 9.81 minus 9.71 is equal 0.1 meter per second square. Okay, so try to make sure that you can differentiate between what is meant by true value, what is meant by measurement uncertainty, and what is meant by measurement error. Okay, measurement uncertainty is called by the precision or the limitation of all measurement devices, irrespective of how expensive those measurement devices are. Okay, this what we have said till now would lead us into two more words that we need to define: accurate and precise. Accurate and precise. Okay, so accurate and precise. So in everyday word or everyday use, we on regular basis can or confidently use accurate and precise interchangeably. I can use accurate, I can say something is accurate, I can say something is precise, and there's not very much of a difference between them. So this is an everyday word, but not in practicals or not in experimental physics. Accurate and precise got two different meanings. Okay, accurate, okay, is how a value is close to its true value. Okay, how close are we to the true value? For example, again we recall the experiment of acceleration due to gravity. True value g is equal 9.81 meter per second square. First student carried out the experiment and he got g is equal 9.65 meter per second square. Second student, he got 10.9 meter per second square. Okay, so what is the difference between this one and that one? 0.16 meter per second square. Okay, the difference between student number one measurement and the true value is 0.116 meter per second square. What is the difference between student number two and the true value is 0.09, oh no, 1.09 meter per second square. Okay, 1.09 meter per second square. Okay, this is difference between student number two measured value and the true value, and 0.116 is the difference between student number one and the true value. Okay, now we can say that the measurement by student one is more accurate than student number two. So the measured value by student number one is more accurate than the value measured by student number 2. Why it is more accurate? Because the measurement error is smaller. Okay, so this is what we mean by accurate. Okay, what about precise? In experimental physics, okay, the word precise means that if we repeat a certain measurement a number of times, okay, they will be said to be precise if they come close or very close to each other. Okay, being precise doesn't have anything to do with being accurate. Okay, accurate, what does mean the word accurate? Is that your measure value is close to the true value. Okay, I can take one measurement. Okay, I did my experiment. I calculated the acceleration due to gravity to be something, a value. I will be accurate if I am close enough to the true value of 9.81. I will be not accurate if I am very far away from the true value. Okay? On the other hand, precise means that if I do repeat my measurement of the acceleration due to gravity a number of times, for example, 3 or 4 times, I measured 3 different values for the acceleration due to gravity, okay, they will be precise if they are coming close to each other. Okay, if the values are close to each other. If they are not close to each other, then the values are not precise. For example, I measured 9.7 meter per second square. I measured 9.9. I measured 10.1. I measured 9.78, okay, meter per second square. Since all those values are close to each other, then they are precise. They don't need to be accurate. Okay? Again, this is precise. Those values are also precise. 15.6, 15.4, 15.3, 15.1 meter per second square. This is student 2. This is student 1. Okay? Now, which one is more precise? So, being precise doesn't have anything to do with being accurate. It means that the repeated values are close to each other. Okay? If we compare this set of values and that set of values, we notice that this is more precise than student 1. Okay, this is a little bit something you have to get accustomed 2, and you have to make yourself comfortable with, okay, the definition of accurate got to do with how close you are to the true value. Okay, precise means if I repeat the experiment a number of times, okay, how close the repeated values are close to each other. Let us go to two more definitions. They are going to be very quick. We have something we call repeatable. Okay, we can call a measurement repeatable, and being repeatable is if an experiment, when carried again using the same setup, we get similar results. What does that mean? Okay, for example, if we if students use the simple pendulum and to measure the acceleration due to gravity, okay, they will always get a value close to 9.81 meter per second square. Okay, so if students use correctly, okay, and wisely a simple pendulum to measure the acceleration due to gravity, they will always get a value close to 9.81 meter per second square, which is the true value. In that case, we call that measurement of acceleration due to gravity using a simple pendulum is repeatable, or this measurement is repeatable, meaning that if we repeat it with the same setup, okay, and using the same method, we expect to get similar results. Okay, this is what we mean by repeatable. We have another word, and it is called reproducible. Reproducible. Then what does reproducible mean? Reproducible simply means if we measure the acceleration due to gravity using different methods or setups, and we get a value close to 9.81 meter per second square, then we say that measuring G is reproducible. So what does reproducible means? Is that if I use different methods, for example, using a simple pendulum, using an oscillating spring, I drop a ball from a certain height, whatsoever I do, I calculate the acceleration due to gravity, I always get a value of, or a value close to 9.81 meter per second square. Then I say this measurement is reproducible. Okay, is reproducible. In experimental science, in physics, in anywhere, it is always important that your experiment is repeatable and reproducible. Repeatable means that if someone carries similar investigation or similar experiment to what you did, okay, he can get similar results to what you had. This is reproducible, repeatable. Reproducible, if someone does same measurement for a certain variable, okay, using a totally different method, and he got comparable result as you did, then your measurement is reproducible. Okay, again, this might be confusing to you from first uh, encounter, but if you go and think about it a little bit carefully, okay, I'm very sure and confident that you will grasp these concepts easily. Okay, I hope this video was of use to you and hope to see you next time.